Welcome back, everyone. So in the last video, we introduced the second intermolecular force of this chapter called dipole-dipole forces. Dipole-dipole forces are in polar molecules, and they are due to the presence of a permanent dipole in that molecule through a covalent bond. So let's use that definition as well and our skills in examining structures and determining polarity to say something about the intermolecular forces and the boiling points of these two molecules, formaldehyde and ethane. So these two molecules, both very similar molar masses, similar sizes. Structure is a bit different though. Formaldehyde has a C double bond O, while ethane just has carbon and hydrogen. So if I was to ask you about the intermolecular forces present in these two molecules, obviously both have dispersion forces, since dispersion forces are common to all molecules, but only one of them would have dipole-dipole force. And that would be the molecule that is polar, and that would be formaldehyde. Formaldehyde is polar because of the electronegativity of carbon and oxygen. If you remember the electronegativity of carbon from your electronegativity table, which you can use on quizzes and exams, carbon's 2.5, hydrogen's 2.1, so the CH bond is non-polar because it has a difference of electronegativity of 0.4. But that CO bond is polar. It has a difference in electronegativity of 1. So formaldehyde, that is a polar molecule. It would have dipole-dipole forces. Ethane has all non-polar bonds. You do the difference in electronegativity between the C and the H bond and the C and the C bond, they all fall within the non-polar range. So ethane is not a polar molecule and does not experience dipole-dipole forces. So knowing that, what could you say about the melting or boiling points of these two? Would you expect them to be similar or different? Well, since formaldehyde has more intermolecular forces it needs to overcome to go from the liquid to the gaseous phase, we would expect it to have a melting and boiling point that's higher than ethane. And that is indeed the case. It takes a lot more, the boiling point and melting point is less negative for formaldehyde than it is for ethane, suggesting that it takes more heat to break apart those formaldehyde molecules, and that's all due to the intermolecular forces that are present. Formaldehyde has dipole-dipole and dispersion, while ethane just has dispersion. Two more molecules, and let's see if we can say something about their melting and boiling points. I have acetic acid and some molecule called 1-propanol. Both have the same molar mass, both the same size. Do they both have the same strength or level of intermolecular forces? Well, hopefully you can see now both are polar molecules. Both have an O and an H bond, so they're both polar molecules. But acetic acid has another level of polarity. It also has a C double bond O. So we've got one dipole here with the OH and another one with the C double bond O that propanol does not have. So because acetic acid has two dipoles as opposed to 1-propanol, which has one, we would expect acetic acid to have a boiling point slightly higher than 1-propanol, and that is indeed what we see. So the take-home message from this slide is that for molecules of approximately equal mass and size, the strength of the intermolecular force, particularly the dipole-dipole force, increases with increasing polarity.